so for question 31, we have 3 statements about germanium and we're trying to find which ones are correct. So 70 is the nucleon or the mass number, so that's the number of protons and neutrons, and atomic number is the number of protons, right? So this is the number of neutrons plus protons, and here it's the protons. Okay, so for this first statement, they told us that the number of electrons in this ion is the same as in the germanium, and it's actually correct because even though this is the atomic number, it also tells us the number of electrons. Because usually atoms, or in general atoms, are neutral, so the number of protons should equal the number of electrons. So in this case, they have 34 protons or 34 electrons, but it has a 2 plus charge. That means it lost 2 electrons. So 34 minus 2 is 32, and that is exactly the same, so this one is correct. And then here they told us that the number of neutrons are the same. Now I told you that neutrons is I told you that mass number is neutrons plus protons. So if you want the neutrons, we're going to do the mass number minus the protons. So mass number here is 68 minus 30 gives you 38, and then here 70 minus 32 gives you 38. It's the same, so that's correct. And they told us that the proton number of this atom is double the number of protons in germanium, and that's true. So 64 divided by 2 is 32 protons. So all of them are correct, and so A is your answer. Alright, so for question 32, they told us that the first ionization energy of chlorine is greater than for sulfur, and they're asking us which factor contributes to it, and well, only the first actually does, so 1, and then your answer would be D. But now I want to know the reason why. So chlorine has more protons than sulfur, so yes, the electrostatic force of attraction is greater, right? So it's harder to lose that electron as compared to sulfur. So okay, so chlorine has more protons than sulfur, right? And of course, the more protons you have, the greater the positive charge in the nucleus. And if the nucleus has a greater positive charge, then the force of attraction between the nucleus and the outermost electron is greater, right? And so that's why it's harder to break that bond between the positively charged nucleus and the electron. And so the first ionization energy of chlorine would be higher, meaning that more energy is needed in order to get rid of that electron. Now here, chlorine has greater electron shielding than sulfur. Okay, so chlorine does have 1 more electron than sulfur, right? However, it's added to the same subshell. And the subshell is 3p. So in general, the increase in the nuclear charge from the protons, so the increase in the nuclear charge, outweighs the increase in the shielding effect. And the shielding effect is just when electrons end up shielding each other. So if there's, say, another electron here, and it has that sort of repulsion because, like charges repel and opposite charges attract. So that's basically what the shielding effect is. However, the nuclear charge outweighs it, and so that's why it doesn't really matter in this case. So now the covalent bonds in chlorine are stronger than sulfur. That is incorrect because it's Cl2 molecule, right? So the distance between the 2 chlorines is greater than the distance between the sulfur bonds, right? Okay, so the distance between these 2 is shorter than the distance between these 2. So more energy is actually needed to break this one because the distance is smaller. That means the attraction between them is stronger. So anyways, 1 is the only factor that contributes to this, and so D is your answer. Okay, so for question 33, we have liquids X and Y, and they do not react with each other, but when they mix, they form a mixture, a liquid mixture said. And they're asking us which statements are correct from the information that they gave us. Now, the mixing of X and Y is exothermic, and that's correct because, as you know, breaking bonds is endothermic. You need energy in order to break a bond, right? But X and Y, they do not react. So no bonds are being broken. However, there are bonds that can form. So like hydrogen bonds, for example, or dipole-dipole bonds, or London dispersion forces can form. So that's exothermic. So 1 is correct. Now, they told us that the vapor pressure of Z is less than the vapor pressure of X or the vapor pressure of Y at the same temperature. So this is something really important. Now, of course, it's going to be less than that because they told us that the intermolecular forces in liquid Z are stronger. So if your intermolecular forces, so if you have Z and more Z, these bonds are stronger, then that means the boiling point of Z would be greater than X or Y. So that's why there's less vapor pressure, because at that same temperature, there's more X and Y gases than there are of Z, right? Now, saying that is correct, right? So then obviously the third one is wrong, which tells you that the boiling point of Z is less than X or Y. That's incorrect. So your statements 1 and 2 are correct, so B would be your answer. Okay, so we have this equation right here, and we're trying to understand why we got different results in the first and the second experiment. Now, something that you really need to pay attention to is the y-axis. So what are we actually looking for? Or what this actually measures is the amount of R, so this. So the first one, it says that a lower pressure was used in experiment 2. Now, this can be correct because we are dealing with gases, and if you use a lower pressure, then that means less R is being formed at a given amount of time. Because look at it this way, so you have these two boxes, and say this is P, the dark ones are P, okay, the filled in ones, and then these are Q, okay? So here is the one with the most pressure because there's just more P in there, and P and Q. Here there's less P and Q, right? We're just gonna imagine that the boxes are the same size. So the chance of them actually bonding or reacting is a lot smaller for this one than it is for this. That's why 1 is possible, it's a good reason. Now for statement number 2, they said that a different catalyst was used in experiment 2. That could be a possibility as well. So the catalyst used in experiment 1 was better than the one used in experiment 2, and it gave them products at a faster rate. So that is a possibility. Now for statement number 3, product S was continuously removed from the reaction vessel in experiment 2. Now see, if S was removed, that means, so whatever change is being made, a reaction will try to, oppose it. So if we're removing more of this, that means there's less product formed. That means that the forward reaction would increase. So we'd have more of the forward reaction than the reverse reaction. And so that would mean that experiment 2 should have a steeper slope. That means we should have more R at a given amount of time, right? So 3 is wrong. So we have options 1 and 2 are correct, so B is your answer. So for the first statement, concentrated sulfuric acid is a dehydrating agent / reducing agent. So if you notice here, chlorine is going to have a -1 oxidation state, and sodium will have a +1. So for chlorine, it has 7 valence electrons. So it only needs 1 more electron in order for it to be stable, quote unquote stable. So it gains that 1 electron, so it has a -1 charge. And if you notice here, hydrogen has a +1 and chlorine again is a -1. So nothing really changed. It didn't get oxidized, so option 1 is out. Now, we have 2 and 3. So they're saying that a disproportionation reaction takes place when chlorine is added to cold water. This is an equation that you're supposed to know, and yes, it is a disproportionation reaction. And the disproportionation reaction is when a certain element is oxidized and reduced. So that's what happened to chlorine. So its original charge is 0, but then with NaCl it becomes -1. With NaClO, it's +1. So if you notice, how did I get +1? Well, look at it this way. Oxygen is 2-, right? As it's in group 6, and it has 6 valence electrons. It only needs to gain 2 more to be stable. And then sodium has a +1, and the overall charge is 0. So how can we get an overall 0? We can do positive 1 right here. So 2 minus 2, or 2 minus 2, so we can do negative 2 or just 2 minus, whatever it is 0. So here, chlorine is being reduced. So oil rig, oxidation is loss of electrons, reduction is gain of electrons. So here we're gaining electrons, so chlorine is getting reduced. Here we're losing electron, so chlorine is getting oxidized. That's why it's a disproportionation reaction, so 2 is correct. Now for number 3, we're getting an acidic solution, right? When chlorine is added to water, because we're forming HCl and it's aqueous, right? So it's in water. That means that there's free ions moving around and there's H+. So the more H+ ions there are, the lower the pH would be, so the more acidic the solution will be. So 3 is correct. So then your option or your answer would be C. Okay, so nitrogen is not reactive, but oxygen and chlorine are. So in the first statement, they're saying that nitrogen has a very strong triple bond, and that is correct. So if we draw the nitrogen, or we do the Lewis structure of nitrogen, it's like this. So N and N, you have the triple bond, and nitrogen is in group 5. So it has 5 valence electrons, or 5 electrons on the outermost shell. So 1, 2, so we have 2 here, then 1, 2, 3. So 2 plus 3 is 5. Here it also has 1, 2, and then there's 3 here, 1, 2, 3. So in total, there's 5 for each nitrogen atom. And yes, triple bonds are pretty strong, so that is a reason why. Now for statement 2, they're saying that the triple bond between the 2 nitrogen atoms is not polar, but the bonds in oxygen and chlorine are polar, which is completely wrong. Both, or all of them, sorry, are not polar, because there's no difference in their electronegativity. Right? So there's no difference. They're going to share that electron pretty much equally. And the third statement, the atoms in nitrogen have a full outer shell of electrons. The atoms in oxygen and chlorine do not have a full outer shell of electron. That is not true, because oxygen and chlorine and nitrogen, all of them actually have full outer shell, as they are sharing their electrons, which is the whole purpose of covalent bonding, which is just, sharing electrons. And so they end up with that full outer shell, just like the nitrogen here ended up sharing its electrons. So now each nitrogen atom has 8 electrons. So if you count it, 1, 2, 3, 4, 5, 6, 7, 8, right? And it's the same for this one, 1, 2, 3, 4, 5, 6, 7, 8. And it's the same for chlorine and oxygen. So the only statement that's correct is 1, and so your answer would be D. So we have tiglic acid, and they're asking us which statements are correct. So the first statement is stating that there's 2 pi bonds, and actually that is correct. Don't let them fool you, because here you have this double bond, right? However, there's another double bond, which is with the carboxylic acid, right? So it's the C double bond O and then OH. So there's 1 pi bond here and 1 pi bond here. So there's a total of 2 pi bonds, because I told you, like last time, a double bond consists of 1 sigma bond and 1 pi bond. So 1 is correct. Now statement 2 states that it contains 4 lone pair of electrons. That is correct. So everything here is fine. But then you look at the oxygen. It does contain 4 pairs of electrons, 4 lone pairs of electrons. So you have 1, 2, 3, 4. 1, 2, 3, 4. So that's 1 pair, a second pair, a third pair, and a 4th pair. Now these are lone pairs because we're trying to get, all atoms in general just want to be stable, right? So here there's 1, 2, 3, 4 electrons, 5, 6, 7, 8. And the 8 is basically that stable number, that full outer shell. And so that's why you have 2 pairs of electrons here. Here there's 2 bonds as well. So 1, 2, 3, 4, 5, 6, 7, 8. And hence it's, it's stable now, and statement 2 is correct. Now statement 3 states that it has all its atoms in the same plane. That's not possible. They're all going to be, or not all of them, but In general, they're going to be in different planes. So if you draw the 3D structure, it looks something like this, for example, just for the CH3, right? It looks something like that. So in general, they're not all in the same plane. So then B would be your answer. All right, so for question 38, they're asking us which compounds on heating with an excess of concentrated sulfuric acid will produce only one product, right? So like I said before, concentrated sulfuric acid is a reducing agent or a dehydrating agent. So these alcohols will end up turning to alkenes. Now, how you're gonna draw this is quite simple. So this OH, this bond will break and then you'll end up with a double bond here. So I drew it right here. Or it could be on this side, right? It can show up on this side instead and get rid of it. It can go either way. However, they're exactly the same. So this is exactly the same as this. It's just flipped. It's like a mirror image. So it doesn't make a difference. So there's only one product here. So 1 is your answer as well. So the first one is correct. Now for the second one, this OH will form a double bond on this side or on this side. Sorry, it can't form a double bond on this side because this one will also form a double bond right here. And carbon, as we know, can only form 4 bonds, not 5, right? So we only have one option for statement number 2, and it's this one. Now statement number 3 will end up with a double bond here and here. Here or here, right? And this does not affect it because all the carbons in this case have 4 bonds. It's the skeletal structure we're doing. So the skeletal structure. So we're not showing the hydrogen bonds. However, in all the structures, the carbons are forming 4 bonds. 4 bonds in total. And so yeah, this one gives you 2 products. That's not correct. That's not what we want. So statements 1 and 2 are correct and B is your answer. Okay, so for question 39, this is a nucleophilic addition reaction. And so we have propanone, and when it reacts with hydrogen cyanide, we end up with this. And this is basically the mechanism. So oxygen is more electronegative than carbon, so it's going to push the electrons towards itself, right? So then the carbon will have a slightly positive charge. Then the cyanide ion, which is negatively charged, is going to get attracted to the carbon. So then it forms a bond here. Now, this double bond is gone now, right? So we have a single bond. The oxygen is negatively charged. This, as we said, is more on the negative side. So delta negative, delta positive. So this negative charge is going to get attracted to the positive charge, or the slight positive charge of the hydrogen. And so we end up with this as the final product. Now, statement 1 states that the cyanide ion is a catalyst for this reaction. Yes, the KCN in this place is a catalyst. And 2, this is an addition reaction. Yes, it is, because we are adding something to it, right? Now the third statement says that the intermediate behaves as a base, right? Now, does the intermediate behave as a base? That is true, because a base accepts a proton, whereas an acid donates a proton, right? And a proton, like we said before, is just a hydrogen ion, because hydrogen has 0 neutrons and 1 proton, right? And it has 1 electron. But when that electron is gone, it just has that 1 proton, so it's literally just a proton. So here we're accepting a proton, so it acts as a base. So statement 3 is correct, and so A is your answer. Okay, so in this question, they're asking us which compounds produce 3 different organic products when hydrolyzed. So when you're hydrolyzing something, you're adding water. So hydrolysis is the addition of water, right? Of H2O. So it's going to break at certain points. So in this point, it's going to break. This is the carboxylic side, so you can see carboxylic acid. So C, double bond O, and then O. But then once it breaks, you have the OH back here. So that's 1 product, right? So this is 1 product. This is another, it's going to break here as well. So this is the alcohol side, this is carboxylic side. But you notice that there's 1 product here, a 2nd product here, and a 3rd one here. So this one is just a methanol alcohol, right? So it's just one carbon, right? So it's gonna look like this, COH, and then the H's we don't draw when, using skeletal structures. So option or statement 1 or compound 1 is correct. Now for number 2, again, we're gonna break one right here, because you can't break it with the carboxylic acid. You can't do that. This is the carboxylic acid side, this is the alcohol side. And then we're gonna break it here as well. Now, even though it's 3 structures, this and this are the same. This is a methanol, which is this. And over here, it's a methanol as well. So you only have 2 different structures. So you do have 3 structures, but they're not all different. So option 2 is wrong. Now, number 3, you're gonna break it right here. So the oxygen, remember, is always gonna be with the double bonded oxygen here, which is the carboxylic side. And we're gonna break it here. So you have in total just 2. So you have this one here and then this structure here. So you only have 2. So even though this is separated, so you have OH, right? And then you have an OH here. Okay, this is really bad drawing, but okay, let me just fix that. It's still the same structure, right? And then OH, and then this one would be a carboxylic acid, right? Double bond. Oh, no, so you only have 2 structures, so that is out. Only one statement is correct, so D is your answer. So that is it for this past paper. I hope you guys enjoyed it, and share it with your friends if you think they'll find it helpful. And